Hello everyone. So today here we are having another question right now. So let's read it out. The electric potential V at any point XYZ is given by V is equals to 3x square, where X is in meters and V is in volt. Okay. The electric field at a particular point, 1 meter is the X coordinate, 0 meter is the Y coordinate, and 2 meter is the Z coordinate. Is These are the options: 6 volt per meter along the x-axis, 6 volt per meter along the positive x-axis. Sorry, the first one was 6 volt per meter along the negative x-axis, and the next one is 6 volt per meter along the positive x-axis, 1.5 volt per meter along the x-axis, 1.5 volt per meter along the positive x-axis. The above one was negative x-axis. You need to remember that this is not just an hyphen. This is actually the negative sign that we have to consider, right? So I think let's start. As you can see, this is quite simple, straightforward question. Potential is given to us in terms of x. X is for x coordinate, right? So you can see the potential does not have a y and z component. So we can say the electric field only exists along the x component or the x axis, not y and z. But as you can see, all the options are having the x axis. So this is not going to let us know which one is the correct option. So let's do it. We know there is a relation between electric field and potential, right? So let's write it down. E is equals to minus dv by dx. This is the formula, right? So first of all, I need to tell you that this is actually not dx, this is actually dr, and we all know that r is having all the components of x, y, and z, right? R is the position vector which can be written in the form of x, y, and z. But right now, since there is only x component, y and z components are not there, so let me show you first of all by breaking it into three parts. Ex means electric field along the x-axis only. So we can write down this as dv upon dx, right? And we can also write down Ey, which is the electric field along the y component. Although we know there will not be any electric field along the y direction, but still let me show you that how this is going to work. And then we have Ez is equals to minus dv upon dz, right? So I'm going to put the value of v. What is the value of v? It is already given to us 3x square. Students, you need to remember that here in this case, the value of potential is given in terms of x only. But sometime in future, the question will come in which y and z components are also given to us, or this completely written in terms of y, or this completely written in terms of z also. So you need to understand. But right now, I'm going to restrict myself as per the question. So I'm going to write down Ex is equals to minus d upon dx, and the value is 3x square. Right now, you know that you need to differentiate it. Let's write down Ey is equals to minus d by dy, and this is minus 3x square, right? And Ez is equals to minus d by dz, and this is 3x square. Right now, I hope you can see very well that here 3x square, and we have to differentiate with respect to z. As you can see, 3x square is a pure constant. It doesn't depend on z. So we can say Ez must be coming out to be 0. In similar way, Ey is also coming out to be 0. But in this case, this is not coming out to be 0 because here 3 can be taken out as a constant, and the differentiation of x square is 2x. You know that, right? So I'm going to write down Ex is equals to minus 6x. Okay, but this is not still completed because we have to find out the electric field at this particular point. As you can see, this is the x coordinate, this is y coordinate, and this is z coordinate. But right now, Ey, Ez are coming out to be 0. So we have to write down Ex, and the x value is actually 1 meter. So I'm going to put this value. Sorry, this is not -1, this is 1. So it is coming out to be -6, and the SI unit of electric field as per this formula, you can see volt per meter. Volt per meter. So the total electric field, we can write down the total electric field. Let me show you how should we do that. Ex plus, sorry, E vector, because electric field is a vector quantity, so we might also write in vector form. E vector is equals to Ex I cap, Ey j cap plus Ez k cap, right? So E vector can be written as Ex I cap, and you can see it is coming out to be -6 I cap plus 0 j cap plus 0 k cap. But since 0, 0, 0 is coming out, so we will neglect it. And the ultimate electric field is coming out to be 6J. And we also have to consider about the direction. So you can see we can divide this into two parts, 6 and minus J volt per meter. So you can see 6 is the magnitude of the electric field and minus J is showing the direction. As we all know, sorry, it should, my mistake, it should not be minus J, it should be I. No problem at all. Mistakes happens. Okay. So 6 minus I cap. Oh, what happened? 6 minus I cap. So you can see minus I cap denote the negative x-axis and 6 is the magnitude. So I can see that the first option is 6 volt per meter, which is the magnitude, and along the negative x-axis. Remember, this is the negative sign, not the hyphen. So negative sign, so that's why the first option is correct. Second option is not correct, not because magnitude is not correct. Magnitude is absolutely correct, but plus x-axis is not the answer because the final answer is having minus I, not plus I. The C and D are already incorrect because the magnitude is not coming out to be correct. So I hope all of you got my solution of this question, which is actually the part of CBSE 2021. I hope it is clear. Thank you very much.